Okay. Um, so hi everyone. Thank you for joining us for the Luohan webinar. And today I'm very honored to have Professor Liyan Yang join us to present the very exciting new work, Does Digitalization Widen Labor Income Equality? So without further ado, Professor Yang, please take it away.
Thank you. Thank you very much for having me here. So this is a joint work with three other co-authors: Jili Huang from Shandong University, Yi Sun from UCAS, and Jian Wang from CUHK Shenzhen. I think they are all in the room. So feel free to ask any questions. If I can answer questions directly, I will answer the question, and otherwise my co-authors will jump in. So let me kind of start with the questions, the motivation. It's very, very simple. We know digitalization is a very important technology revolution, and people often see digitalization is the fourth industrial revolution. The previous three are the steam engine, electricity, and information technology. Also the two natural questions in economics often we ask are the economic growth and the income inequality. So basically, how these technologies will change the size of the pie, and then how people will divide the pie. These are two important questions. And I think so far, the majority of the literature has focused on the first one, the growth, the economic growth part, and also focused on mainly just one element, which is automation. And also some papers also focus on the big data element of this digitalization. Relatively speaking, the research on distributional effect on income inequality, relatively speaking, is not as much as the research on economic growth. And also the existing literatures, they typically suggest that the positive relation between technology progress and the income inequality. And this is not just by incident, because in the past, this is the fact that some empirical facts showing there is increasing inequality between group and also within group, and then the papers, the theories try to explain those facts. And so now we try to see whether this digitalization will be different. If it is different, so through which channel it will change the inequality in a different dimension. So that's a kind of very simple question, which we want to ask how digitalization affects income inequality, and that's a motivation. And before that, let's kind of answer what is digitalization. Digitalization, I asked DeepSeek asked this question. So what is digitalization? It's a buzzword in the digital economy. So digitalization, automation, or big data, all these kind of things very kind of often showing up in our daily life. But it's very broad. And if you ask a DeepSeek, it said digitalization is a very broad concept. It basically refers to translate everything into a digital form. And it has a lot of elements. So one key element indeed is automation. That's why the economic growth literature has focused on automation. And also there's some other elements. For example, that also kind of enhance the connectivity. You think about the Uber, so that can help the riders and the drivers better connected, or some platform like Taobao, eBay, and this is much easier than the previous situation without the platform. It can help people to better connect it. So that a lot of elements of our digitalization. So automation is just one element. There are also other elements. It's more like, I think digitalization is more like an infrastructure. It's translated things into digital form, and this digital form can facilitate or generate some extra things. Those extra things will help people to achieve a better life. So this automation is one of them, and big data and innovation, and this is a lot of kind of derived things from this digitalization. Digitalization is more primitive. It will affect all aspects of our life, and automation is just one of them. It's just one implication from this broad concept. So now, so in this paper, what we do, we try to write down a very, very simple model. It's very simple. Try to build a simple framework to understand this situation, try to capture some aspects beyond automation, and those aspects will affect labor inequality. So now in this slide, I try to tell you how four of us, our course and myself, think about this question. And in the next slide, I try to show you a picture to explain better how this digitalization affects the economic growth and income inequalities at which level, and also how it is related to the literature. So in words, in the literature, people think about digitalization affect the economic growth. But basically, it works through production function. You think about how kind of the capital will replace labor. And in that literature, people also talk about this the employment. So because it's the replacement of capital and the labor, and this automation will replace labor in the old task, but it will create a new task that will increase the employment. It's about the kind of employment. And then there's also some studies studying how digitalization affects the consumption directly. So for example, it will create some new things that you can enjoy. It's a variety of these kind of things. It's all R&D or innovation or all this kind of direction. This is about production function. And if you think about income inequality, think about the labor income, we might have to go upstream on the supply chain ladder. So go to the labor market. The labor market will generate the labor income. And you think here people will divide them into kind of high scale and low scale. This kind of a way of the literature to model rich people versus poor people. When we talk about inequality, we often talk about how rich people will perform relative to poor people. And then you think about how to define rich people. And in the literature, people just give them some endowment and something that make them richer. The talent is a skill that will make them richer. You can think about skilled labor versus the unskilled labor, relatively speaking, rich people versus poor people. And we think at least there are two directions or two sides through which digitalization will affect the labor income. One is about the labor demand, the other one is the labor supply. Let me give you some examples. You think about this digitalization as a creative disruption to the existing human capital. Then in the old human capital, the unskilled labor, they might become outdated as this new digitalization or new technology arises. So this will affect the productivity of this existing skill. So we call them routine obsolescence effect. So this word is very difficult to pronounce. Obsolescence means it's outdated. So those some low-level skills become obsolete, or become outdated. So this kind of the quality, the production of those skills. So this is about the demand side. So how the firms will require this labor, demand this labor. And the workers, they are also proactive. So we think about the supply side. So we think this we call them time augmentation effect. So basically it refers to quantity. So now let me give you another example. You think about that Uber, the Uber example. So before digitalization, before Uber appears, and the drivers typically they have to drive around to find a customer, right? This will a lot of waste of their time. So now, the app can give you personalized recommendation. If you are close by, and it directly will match a rider with the driver. So that can save a lot of time. So this will effectively increase the amount of time, the work time of our labor. And also another example is you think about this, these workers, they also have to learn when they are learn the technology. And this digitalization, some software or this kind of new technology will help them to learn quickly. That will save their learning cost, so they can spend less time on this learning. So that can also effectively increase the quantity. So in this way, we try to think about the multi aspects of digitalization, and some aspects will affect the quantity, some aspects will affect the quality. The quality will link it to the labor demand, and the quantity will link it to the labor supply. So that's kind of how we kind of at the concept level think about digitalization affect the labor income, labor market. And then I talk about the rich people versus the poor people related to skills. And we also try to determine the skill level. And then we give the workers a choice, an occupation choice. And that will determine kind of the level, the composition of high level skill and low level skill and rich people versus poor people. And so we can talk about this inequality between group, within group, often showing up in the informal conversations. So that's kind of conceptual framework we try to offer. The next slide, we draw a picture to show our idea, and also connect our paper to the existing literature. You can think about the entire economy as a supply chain. You have upstream, downstream, and you from up to bottom, it's more from upstream to downstream. So the existing literature mainly focus on the bottom, on the production side. Basically, this is automation literature. You can think about like this. So each level has a production function. So initially, in each period, there's a generation of workers, new people coming, and they will they have different abilities. This ability they will determine their equilibrium skill level choice, occupation choice, will determine whether they're rich people or young or poor people. This is the endowment. And then some people will become skilled, some people will become unskilled. And at this moment, this skilled and unskilled, they try to think about how much time they can supply to the labor market, and digitalization will affect this, have the effect. So in our model, we use one parameter beta. This beta will have an effect at this level. This beta, so when you see the red thing, that is something the digitalization element. So this red element will tell you, so this will have a rule element, this digitalization will have a rule at this moment. So the literature is about automation. If you are familiar with this literature, what they do basically is about the task model. You think about the production of GDP is coming from different tasks, and this beta will tell you this kind of it's more like a CES function. In the limit is tell you how many tasks can be automated. So this beta is the same thing. So this is we see this beta just have different elements, different aspects. Automation will affect the mass, our tasks that can be used can be automated. And in the labor supply, we think, as I mentioned, so if you think about the Uber, you think about this learning cost, that can effectively increase the unit, the amount of labor supplied to the market. It's about the labor supply. And the next level is about the labor demand. This is the task level. You think about the task can work at the intermediate good concept level. So the task can use either labor or capital to be performed. So some tasks can only use labor, some tasks can only be used by capital. And if you can, the task can be performed, executed by capital, that's automated. If not, it's not automated. So here, this skilled labor and unskilled labor will produce some, we call it composite labor. So the composite labor basically is a composition of high skill and low skill. And you see here, there's the production. The high skill has the production of gamma, which is larger than 1. So that's the production of high labor to the composite labor. And for the low-level labor, its production is 1 minus delta beta. So there is a deduction from the production. So there's a lower than the high-level skill productivity, and also related to this digitalization. This captures the fact that digitalization is a new way of technology, and the low-level skill will be outdated, partially outdated. This delta will capture the depreciation rate. So this labor supply and the labor demand, these are the two ways how we think about digitalization will affect the labor market. And the next level, the next two things are the economic growth on automation, basically. So this composite labor will go to non-automated tasks, and then also automated task will be produced by capital, and this automated and non-automated task will go to the final GDP production, and here you have the mass. The mass beta will measure automation. And to summarize, you can think about this entire world as a supply chain. And since we think about this digitalization, this beta will affect a lot of elements, a lot of aspects of the economy. And our focus is on the labor market, which is more on the upstream sector. And the literature focuses mainly on the downstream, which is about the automation. So this is how we think about the framework, concept level, and how our paper related to the literature. Okay, I pause a little bit. I see whether there's any question. Yeah, I saw you turn on your video.
So can I ask a very quick question?
Yeah.
Number one, when we talk about economic growth, look at the previous classical growth model. Economic growth depends on AT over 1 minus alpha. AT is TFP overall. Okay, 1 over alpha. Alpha can be, CDS, alpha could be capital shares. So digitalization, you can improve TFP, AT, and also capital share. So which direction we want to go? It's number one. Number two, so since we have a labor market, where's sorting, searching, and the friction here? You have demand, supply. Sorry for that.
Thank you very much. That's a great question. Indeed. I think so. The literature on automation, they talk about what you exactly asked. They think about how to think about technology. So what you mentioned that AT is called I think it's called factor augmentation technology. And this beta is about extensive margin. It's about how many units of task can be automated, and then also some intensive margin given the kind of the automation. So what will be the productivity of each unit of our key capital, the capital or labor. So they like the ZT here in our model. So I remember the literature talk about the 4 types of technologies related to this technology progress. And here we sort of abstract away from that discussion, and so it's all about the downstream. I just in our model, what we do, we use that growth model as set a stage to write down. It's not even uncertain. It's deterministic. It's mainly just a set a stage, and we focus on the top. So that's kind of the answer to your first question. Indeed, you can think about digitalization affects the A, affects the beta, affects the Z, affects all of them. So, but we didn't talk about that. So that's the first answer, the correct answer to the first question. So the second one, it's also a great question. It's about how digitalization affects the search and the matching between labor and demand and the labor supply. That will that's a great suggestion. So for that direction, we need to write down a search model to think about the labor, the workers try to search the demand, and matching intensity will be affected by digitalization. That's more like a micro foundation. I think that's the micro foundation of digitalization affecting labor supply or labor demand. So what we do here is relatively reduced form. We still think about like the Econ 101 class. You think about the demand function, supply function, and the market clear condition will determine the equilibrium. And we use a reduced form to think about the beta will affect the supply, and the beta will affect the demand. So this is more like the reduced form. What you suggest is a micro foundation to microfound our assumption here.
Could I ask a question about your?
Hi, Chris. Yeah, thank you very much. Thank you, Chris.
Yeah.
Yeah.
I mean, do I understand correctly that the kind of new innovation you have in the paper is based on the assumption that the cost of learning is easier with digitalization?
That's one direction. Yeah, that the cost of learning is easier. That's reflected in the labor supply here. So what we do precisely is we just assume the amount of labor supplied by each type of worker will increase with digitalization, which is the beta here. Yeah. So they have a different sensitivity. The interpretation is either the cost of learning become lower, so that can effectively increase the amount, or like what Yi just mentioned, that can be better matching. So you think about the driver, you don't have to drive around to find a customer, and you can just wait and immediately recommend it by the app, and you know where the customer is. That will effectively increase.
I understand your amount. Your time is limited, so don't tell me the same things that you said before.
Okay.
What I wanted to say though is that so far, everything I've seen on digitalization and work that we've done, empirical survey work and all that, is exactly the opposite. The cost of learning with digitalization is much higher. I can give you examples that I find more convincing than what you said. You agree that the biggest innovation before digitalization was electricity. Okay, everyone says that. Now, electricity replaced steam power. Which is easier for the worker to operate with, steam power or electricity? If you go to any science museum, the engines they use for steam power fill up whole rooms. They are complicated. People got burned. They are great big things that turn, coal that burns. Electricity, you just press a button. It's much easier to learn. Digitalization, though, what is replacing is that a worker goes to the office and has to learn how to use software, how to operate them. I agree with you that Uber drivers are saving idle time that taxi drivers were queuing, and that's an increase in efficiency rather than learning. But to learn how to use that technology is complicated enough. They're always looking at their phone, they're pressing things, they're looking, it's not trivial. So, like, intuitively thinking of examples, if you ask me, I would put my money on a higher cost of learning under digitalization. If you want to persuade us that the cost is lower, you need to show us some empirical evidence, some actual calculations, not just take one or two examples that may or may not be true and say, therefore, this is it.
Okay. Yeah.
Right?
Yes, thank you. That's a great suggestion. I think probably, that makes us to think about this sharper. I think what really matters, we think, is the difference between these two loadings, eta S and eta U, the two loadings. It's possible. In some situations that will reduce the cost of learning. In some cases, this will increase the cost of learning. But maybe for higher skilled people, it's easier for them, relatively speaking, to learn the new technology. So it's like I call this as a labor augmentation effect. You may call it a labor reduction effect. But what matters here is the difference between skilled and unskilled. So this is eta S and eta U, which will be the loading, how this sensitivity, how this digitalization affects this labor supply. So it's possible, Chris. You mentioned is the cost of learning can be higher, can be lower. But I think we agree that this is for skilled and unskilled labor, this will be different. So we change the title, we change this name. We don't call it a time augmentation effect. We think about another name. It's basically the quantity, but it's different for skilled versus unskilled. I think that's basically the difference between eta S and eta U.
I don't know. I mean, my suggestion is just to focus on the efficiency gains, ignore cost of learning, unless you can provide evidence, actual calculations that's less. I mean, honestly, I mean, we talk to nurses in hospitals that have been adopting digital technologies, automation. They're desperate. They said, oh, before we were standing next to doctors, we were talking to them, they were telling us to do, finish. Now, every time we want to decide what to do in an operating theater, we have to go and look at the computer screen, remember what we learned. It's more difficult. That's what they say.
But difficult because they don't have a degree. If you have a computer science degree, it's much easier for them.
Yes, but what fraction of the labor force has a computer science degree? I mean,
that's high skilled labor. If you have high skilled labor, so your supply will become effectively higher.
Well, that's the evidence you have to provide.
I got it. Yes. I got it. Yeah, I need some empirical evidence, not only conceptual level or anecdotal evidence like the Uber drivers. Yeah. Great. Yeah.
Driver is efficiency, but using the technology, there is a learning cost to learning how to use the apps, the Uber apps that they have.
That's easy, right? Uber app is easy. I think
but before they didn't have to learn it. Now it's learning it. Even if it's epsilon, it's plus epsilon compared with before. The efficiency, I agree. not having to queue to get, or not having to drive around looking to see if someone hails you down. That I agree.
Yeah.
But these are two distinct things: efficiency gain or learning cost.
Okay. Yeah.
All right. I'll let you
Okay.
go.
Thank you. That's great. That's very great. That we need to sharpen this channel. At least the terminology we need to change. It's not only time augmentation.
Right.
Thank you, Chris. So now let me move on. I think this is the key findings. So the key findings we try to deliver two messages. The number one is so whether digitalization increase or decrease the income inequality depends on which measure or which content you look at. So either the between group inequality or within group inequality or Gini index. So for example, you take the between group inequality as an example. So digitalization in our model, it will widen the wage inequality through the labor demand channel. It can either widen or reduce the wage inequality through the supply channel. So for the demand is the kind of the skill outdated effect. It always kind of be beneficial to skilled people, and so that direction is clear. But for the supply channel, and because the eta S and the eta U, I just discussed with Chris in the previous slide, so that can change. So either the digitalization will widen or reduce wage inequality. That can change because you have two directions. Either eta U is higher or eta S is higher. It depends. And because these two channels, both of them are working, and the relation between wage inequality and digitalization is non-monotonic. It can be non-monotonic. So that's kind of the overall message. The next, I try to bother you with some model, some notations. So first, let us tell you the model. The model is super simple. So we do it on purpose. So it's basically economic growth model. This is a framework developed by the literature. We just use it to set a stage. So here the digitalization, we try to capture two things. One is automation. So this is not the focus of the paper. We just to borrow the shell from this literature and build a model. And that's kind of the work base of our paper. And then the key is this. Is about the labor income. This is Gala and Mo, the 2000 QJE paper. So we introduced that framework into this automation model, and to think about how individuals make their occupation choice, how digitalization affects supply and the demand channel. So this is kind of the overall picture of the paper, how it looks like. Although it's dynamic, but essentially you can think about this as a one period model. It's very, very simple. And the time is discrete and lasts forever, and then no uncertainty, everything is deterministic. The one GDP good, it produced from many tasks. You can think about those tasks as intermediate good. And the task can perform either by labor or by capital. If it's about by labor, it's non-automated. It's about capital, it's automated. So in the literature, people also talk about the combination of labor and capital. We just use the most simple version to capture automation. In each period, there's a new generation of the individuals. They will come and decide their occupation choice, depending on their ability level. It becomes skilled or unskilled, and then they supply the labor, and the intermediate good producers will hire the labor and produce the task, and task will go to the GDP production. And the digitalization will affect, as I said, both the task production, this is the labor demand, and also the supply of the workers. So this will be the focus of our paper. So if we think about how digitalization affects within group and between group, and also across the entire society, the wage inequality. Okay, so this is about the growth part. This is a very standard. It's not a focus, but we try to set a stage. So the GDP is the final good. It's produced according to a CES functional form. So this is VG is a task. This is basically CES. So in the literature, people model this digitalization and automation is just use a mass beta. So a fraction of beta will be produced by capital. So according to this linear functional form. So this ZT is the production. It's also deterministic. it will have a growth rate of this GDP. And the key is the capital hired by this intermediate good producer. And this key is from final good. The final good is always the numerator. So the remaining mass, the remaining Y minus beta, also there's a typo here. So it should be beta T to 1. So the remaining Y minus beta T, this is not automated. So this is produced by composite labor. I will introduce composite labor later. This will be a combination of high scale and low scale. And this is the non-automated part. And then because the final good and intermediate good are produced by competitive firms, so after very standard derivation, you will arrive at the following. Basically, the average production is given by a CES function form. So basically, the previous slide is the micro foundation of this CES function form. So this key is the overall capital, L is the overall labor, and this Y is the growth. And you can see here the economic growth will be driven by these two parameters. One is beta, the other one is Z. Beta will be automation process. Z will be a production of productivity of the capital. Now let's specify them. Specify the dynamics. So we assume digitalization and automation evolves according to this. So in the previous period, you have a beta T fraction of automated work, automated task, and the remaining is Y minus beta, a fraction of them, which is theta exhausted given, will become automated the next period. So that will imply a growth rate given by this. This is deterministic. And we also assume the productivity of capital is ZT is related to this production, is dynamics of digitalization automation according to this linear form. We make this assumption because we want to get a GDP, BGP, balanced growth rate, balanced growth rate path. So only make this assumption in equilibrium, the capital will increase at a constant rate. This is just a technical assumption. And you will see under this assumption, everything will be on the BGP, balanced growth rate path. So this is the growth rate of beta, this is growth rate of Z, and they are deterministic. And in equilibrium, the GDP and the capital will be increasing at a constant rate. The labor will be fixed at a constant. So that's what happened in this economy. This is just the setup. So we just borrow the shell from this literature and to set up the stage. So next will be the real meat, will be the real element of the paper. So this is about the labor market. It's about the upstream sectors. So in each generation, you think about that the new generations of each period, new generations of individuals will come. At the very beginning, they will make a decision about their occupation choice. So occupation choice will, you think about this correspond to degree. If you want to become skilled, you have to participate in some education program that will take your time, and then you will have some ability to acquire high skill. So we call them a skilled. This will be rich people. It will be determined by their ability, endowment or ability. And the unskilled will be the remaining. This will be L. So here, once you choose your choice, your occupation choice, and then you will go to the labor market, go to the employment market. So the labor demand is determined by the action of the task producers. So the task producers, when they hire labor, the composite labor, they will discriminate the low-level labor, the low-skilled level labor, because their skill level is not adapted to the new technology. So there is a erosion effect. So that's what we call it a routine obsolescence effect. Routine means low level, obsolescence means outdated. So this means the low level production and low level skill will be discriminated by the producers. So this is about the supply and the demand. Now let's think about the supply. The supply I mentioned many times. So we basically think about the digitalization will change the quantity of the labor supplied. So either through affecting the matching or through affecting the learning. So now let me go to the demand first. We call it the routine obsolescence effect. We make it very simple. It's just linear, basically. The composite labor is given by a high scale labor and a low scale labor. It's basically the gamma is the production level, production activity, and the environment delta beta is the production technology of related to the low scale labor. You can interpret it as a production function. As I mentioned, the entire economy is basically just a supply chain. So some input produce output, output will be used as the input for the next sector, and this is supply chain. So this L is the production, the output. This H and L will be the input. This gamma delta beta will be the productivity. So this gamma is larger than 1 is the productivity of skilled labor. And this very much delta beta will be the productivity of unskilled labor. And this delta is the depreciation rate. So this delta beta will capture the routine obsolescence effect, basically. This is how digitalization will affect the labor demand at the conceptual level. Okay, now you think about the workers. In each period, the new generation of workers, so they have different abilities. So that abilities is given by AIT, is uniform between 0 and A. So this A is also given. In our numerical examples, we set A as 2. It's ID across the time, across the generation. Basically, in each generation, each period, there's a cross section of individuals with different abilities. So this ability will affect how they adapt their human capital to the new technology. So there is a trade-off. You think about if you want to become skilled labor, you have to attend some pre-job training. So this will be captured by this course at the top. So basically, you have to spend a fraction of your time to learn some program, to earn some education, some degree, learn computer science, get something. You have to know what's happening in the new technology age. So that's a kind of a cost of becoming skilled labor. So that will because of this cost, so it's intuitive in equilibrium. Only the high capacity, high ability people will become skilled people. They will become richer. And now this is about the time effect. We call it the augmentation effect, but as Chris mentioned, they may not always augmentation. It might be reduction. So this is what we do. So for the unskilled, it's also make it very, very simple, just linear. For the unskilled labor, the worker, so they have 1 unit of their endowment, their work time. So this one is basically the average level of the ability. So it's equal to 1. We just assume it is equal to 1. And then digitalization will affect their labor quantity. And we make it simple, just add them together. So this the beta is the digitalization. So eta U is kind of occupation specific factor. So that's a constant. And this AIT is their ability. So when their ability is higher, and they are also better to augment their time. So you think about the driver, if they have a better ability, it's easier for them to save their time, the waste of time. So this is for the unskilled labor. For the skilled labor, so we have the endowment is given by AIT. This is basically said because they learn the new skill, so their endowment will start with a higher level related to their ability. And they're also similar time augmentation effect, similar to the unskilled labor. And because they have to learn education degree, so they have to spend a fraction of their time. So that's why the environment is tall. So this is kind of the labor supply side. Okay, now you think about occupation choice. So the wage to the composite labor is basically marginal productivity of labor from the growth model. So you will see that this WT will just a factor. So some of our model make it very striking. So the automation will affect the level. It will increase the level of wealth. And the two things we talk about, the labor supply and labor demand, will affect the composition, affect the distribution. So that they will see that it's we make it on purpose. It's very striking. So given the skilled labor, their productivity is given by gamma. And so their wage rate is gamma multiplied by WT. So similarly for unskilled labor, their productivity is environment delta beta. and their productivity multiplied by the wage rate, that will be their revenue. And so the skilled worker, their total income is their wage rate multiplied by the quantity. And so you can, this the unskilled is their wage rate multiplied by quantity, and you have to compare them. You compare them, which income is higher, they will decide which category they will belong to. So in equilibrium, so only with the ability higher than a threshold value, and they will the individual will become skilled. Okay, this is the model part. So the next, I try to move on to the results. Let me pause a little bit. I see whether there any question about this.
Oh, Professor Yang, I have one
Yeah,
quick,
yes.
maybe.
Thank you, Ilu. Yeah.
If we go back to the labor function for the unskilled worker, if when we compare this, basically when we compare this two that drives the result, this selection, it seems that a key assumption is for the unskilled worker, their labor equals 1 plus this time organization part, but the skill equals this A plus. So this
this is
1 with its ability A, then actually it seems like then the two functions are almost like similar to each other. We might not find the worker selection results. So is that a more standard question? Like if we replace this 1 with A, is that a strong assumption? Or
thank you. Yeah, thank you for the great question. Yeah. We also struggle a little bit about this one. It's about whether we want to change this A to 1. If we change A to 1, the result will first of all the result will not change. And we make this, keep this assumption, you just want to capture the direct benefit. If you acquire skill and maybe you better know the technology, so it's related to this kind of direct effect of productivity effect. So we think this will not, this is also realistic. So why, if you change this equal to 1, the result will not change? Because what really matters here is about this supply, is about this eta U and eta S. So as I discussed with Chris, so what really matters is the difference between eta U and eta S. So that's kind of the supply effect. So whether that will be beneficial to high labor or high skill or low skill labor. So that's to answer your question, so whether that will change the result. But your question is very relevant. We also struggle with this. Think about whether we make it equal to 1 or AIT. There's some artificial result related to this assumption. Okay, so now let me talk about the result. I have about 15 minutes, I think. So that the result is, so in this economy, the stated variables is given by two vector variables. One is beta digitalization, the other one is WT. So WT is kind of only a level effect driven by automation. It will not affect our result. What really matters is the beta T through the labor market. And so we care about the following things. So first of all, the occupation. So we think about how this digitalization will change the composition of workers, because this is related to how many people will become rich, how many people will become poor. And after we get this, we will talk about the between group inequality. We think about how much wealth is controlled by the rich people, how much wealth is controlled by the poor people. And if also you think about a representative of poor people, representative of rich people, how their wealth compared with each other. So this is the between group inequality. And we also want to think about the within group inequality. Given the poor people, given the rich people, what will be the Gini index within the group? And also we want to talk about the entire society, pull them together, we think about the Gini index. This is kind of the 4 things we care about, so in terms of variables. And now, let me talk about this is essentially just a one period model. Although it's dynamic, we just borrow a dynamic model, it's just borrow a shell from the economic growth model, but essentially it's one period. It's based on the BGP. So everything will depend on this beta. So the occupation choice is determined by a threshold, which is given by this AT star. It's explicitly given. It's endogenous but explicit. It only depends on beta and also some exogenous parameters. This delta is the labor supply channel. This eta will be the labor supply channel. And the income of skilled labor is given by this WT, which is the wage rate per unit of composite labor, and multiplied by a function. This function is related to this ability, related to the beta, related to the eta s. So that you can, it's also explicit. So this WT is a level effect driven by automation. And because we care about the ratios, the composition, this WT will not affect our result at all. So we can completely forget about them. And the labor of unskilled similar is given by WT multiplied by a function. And again, so this WT will be irrelevant. So once you get this, everything is very, very simple. You just do the first order condition or this kind of calculus derivations. So undergraduate class of exercise. So the fraction of skilled workers given by the threshold A star divided by this total mass of our workers, we call it rho T S. It will only depend on beta T. So we highlighted this dependence of beta and delta, eta, and we just want to highlight the supply channel and the demand channel will affect this. And the fraction of skilled wealth is how much wealth is controlled by rich people. You just add with the rich people's wealth and divide it by the total wealth. That's a fraction of our rich wealth. And these are two things we want to know. And also we want to think about you think about a representative skilled worker and also think about the representative of unskilled worker and compare them. And what will be representative? Either you think about the average or you think about the median. And so in our model is irrelevant because it's a uniform distribution. So we simply just take the median. The median is the average average skilled workers' wealth over the average unskilled workers' wealth. So we call it the sigma. So we care about these three variables. And next, we want to examine each dimension, the delta, eta u, and eta s. We want to examine each of them separately and plot three figures. We can prove them, all of them analytically. I just want to show you the result and graphical to make it very simple. The first one, let's look at the demand channel. The demand channel will be the shutdown supply channel that only called the routine obsolescence effect. So the first channel is the first panel is the benchmark. Everything is gone. So there's no supply channel, no demand channel. So no matter how you change the beta, so everything is constant. That's by construction. Okay. The second panel, let's increase delta. Basically, you turn on the demand channel. Demand channel means if you have more digitalization, so this is a new technology, the old skill become partially obsolete. So that's the depreciation rate that's given by this delta. So this will be favorable to skilled, unfavorable to unskilled. That will encourage more people to acquire skill. As we think about it, okay, it's more worthwhile for them to acquire a degree. So as a result, if you increase the so the fraction of rich people will become higher. And also because the fraction of rich people become higher, and also they make more money. Because their productivity is relatively constant at gamma, and the productivity of unskilled people is decreasing. So you can see their money, relatively speaking, their wage will also increase. And both forces, so the number one and the number two, will contribute to more fraction of their wealth. That's why you have the middle also increase. And you further increase the delta, the result will be similar. So if you just compare this to first two, the result will tell you the result. This is the kind of demand channel. So next, let's look at the supply channel. The supply channel, we shut down the demand channel. We look at the eta u and the eta s. So recall the supply channel means this. We call it the time augmentation effect. Basically, if you have more digitalization, either because of better matching or because of the kind of reduction of kind of difference in cost of learning, so that will drive the result. So what we do is, first of all, the first panel is again the benchmark. So we have everything at zero, everything constant. The second panel, panel B, we will increase eta s and keep the other two at zero. So meaning, so if you have more digitalization, that will increase the amount of labor to supply the people, to skilled people. So that will be beneficial for skilled people. As a result, of more people will become richer, become skilled, and also their wage will become higher, and so the overall wealth will become higher. So this is, you see, that this dimension is very, very similar to the demand channel. But if you compare, if you look at the different exercise, you shut down the eta S, but you turn on eta U. So eta U is the supply channel will be beneficial to the unskilled labor. So the result will be the opposite, basically. The result will be opposite. So fewer people become richer, quite skilled, and their wage will become lower, and they can also dominate, become downward sloping. So this you tell you the supply channel can have two forces, two opposite forces. Because of this, the result, if you turn them all of them on, the result can be non-monotone. So this is something we turn them on, all of them on. So basically, we want to keep eta and delta, all of them positive, and then we look at the interactions. So here we also do some exercise like this, the thought experiment. So the first one, the panel A, we have eta S, eta U equal to 0.3, and we have a delta equal to 0.1, and so this is more like our benchmark, and we compare with this. And so this, you can see this is more similar to that demand channel because the eta S, eta U the same, they will cancel each other. And for panel B, we increase eta U, that will make the technology change more favorable to unskilled labor. Now you can see you have this non-monotone relation will show up. You have this one the non-monotone, this one the non-monotone because of that two forces. So in panel C, if you increase eta S, because eta S is working in same direction as the demand channel, so as a result, the panel C and the panel A will be very, very similar. So that's sort of very intuitive because everything is very analytical, it's just more like a one period model. So the intuition is very, 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 very straightforward. I think you I have 5 minutes, right? Or 2 or 3 minutes? 5 minutes.
5 minutes, around 5 minutes. You can
okay,
go.
About 5 minutes. Okay, I try to tell you the result. Probably I don't have enough time to explain the result. Tell me what we do next. We also look at the within group inequality and the Gini index of the entire society. So this is the within group inequality. Basically, for example, for the rich people, we can compute the Gini index for the rich people. Because our model assume uniform distribution, everything is linear, it's very simple. You just look at the top to bottom earner. The top to bottom earner, and will give you the Gini index, the exactly same. So this A is the richest person. AT star is the kind of the poorest person in this category. The poorest person in the rich group. So that's called the theta TS. And the theta TU is similar. We compute the top earner versus the bottom earner. And we plot beta T against plot this sigma TS, sigma TU against this beta T. And we also look at the demand channel, supply channel, and both of them. Okay, so the first, this one, I just try to explain this one. This is the within group inequality of skilled workers. The first panel, the first figure is everything is shut down by construction. There's no effect. And then you increase demand. If you increase demand, you will increase rich people category. And you increase rich people category, you make rich people more diverse. So as a result, so their Gini index will be higher. So if you increase data further, the Gini index will also become higher. Okay, I think there's some different results here, and you can see, but basically, the message here I want to tell you, so the supply channel and the demand channel will affect things differently, and also will affect the between group and the within group differently. So that when you talk about the inequality, you have to make sure the context, which inequality you talk about, and also talk about which channel. Okay, so the next, this within group inequality of unskilled, and so now I use the remaining 2 minutes to talk about the inequality across the entire economy. So here we compute the Gini index in this entire economy. Consider both the between and the within group, everybody, and so we compute the Gini index. The Gini index basically looks like this. You rank the individuals from the poorest to the richest, and you look. This is on the horizontal, and compute their cumulative wealth, and this will give you the so-called Lawrence curve. Then the king here, the king will be determined by the endogenous composition of skilled and unskilled labor. And the Gini index basically the mass of this shaded area. So this, if it's purely equal, it will be on the 45-degree line, and as long as it deviates from this, and that is some inequality. Okay, and we compute this, and this is the result. Okay, this is the result. If we compute this is the result. It's very kind of very similar to what we did before. We have the demand channel and the supply channel, and all of them work together. And I also want to emphasize one thing, and the Gini index can also operate with different from also work for different from other index. So for example, this is one example we look at. So here you focus on this panel. This is something very interesting we found. So this is the Gini index versus the between group. This is the between group inequality. So the red is the Gini index. The red is the between group inequality. So the red is between group inequality. The G is the Gini index. And you see the Gini, if you increase beta, the Gini index always increases, but the between group inequality can be hammer-shaped. Okay, so this is, if you think about the Gini index, it's kind of a measure for inequality across the entire economy. You think about between group inequality, it's roughly, we think it's kind of related about how rich people, how much wealth controlled by rich people, and how many people are rich. It's kind of somehow they are rich to be related, but they are not related. Not exactly related, but it's not related because the composition of rich people and poor people also endogenous. So we also conduct a thought experiment. So once we fix the fraction of rich people and poor people, this result will disappear. So that the endogenous composition of poor and rich drive that result. The difference, the divergence between Gini index and the between group inequality. So I think that's pretty much what we do. And I give you some summary. So what we do here is we try to provide a very, very simple model to think about how digitalization affects labor inequality. We focus on the upstream of the economy, and we think about this will affect labor demand, labor supply, and also the composition, the occupation choice. This will capture different aspects of digitalization, different from automation. And we think that this gives us some thoughts on how digitalization affects wage inequality. Thank you, Matt. Thank you very much. I'm going to stop here and see whether we have more questions.
Can I ask a question?
Hi, Long. How are you? Thank you very much.
Yeah. Finally, I get a chance to ask.
Thank you.
So I'm trying to, maybe I do not understand enough, but I'm trying to sharpen your points. And I'm very happy that Chris is here. So I think I'm trying to see the contribution of this paper. Now, my understanding is that the issue is, the question is, what is the impact of technology on income inequality? And I think your point is that it's not just one direction, right? It's not it's complicated.
Exactly.
Depends on its impact.
Yeah.
And it could increase or decrease.
Yeah.
But my point here is that this is actually a general issue. This is the issue not specific to digital, but it's general to pretty much a lot of technologies. That's my first question. So my point is that you are talking about a general issue. You're talking about the role of technology. So I guess that will come back to my later comment. But anyway, my point is that this is a general issue, and I kind of agree with you that it's specific. Now, my first point, you helped me to think about this, is that let's think about historically how this is resolved. I think historically the main lesson is that we push for the growth first. And there will be some people that will be left behind. Historically, the way to solve the problem is they turn into different sectors, from agriculture to industrial or service. So, and the government should do something to complement this, to help the transformation, because this is a theme. This is again general. I still remember last time Chris, he gave the talk at our Frontier Dialogue. He talked about that it might not increase the unemployment rate, but practically many people might not be happy, and many people will go to maybe service sector, but the income is not so good, and are they happy about it? But this is the general theme. I think that's just the way it is. So I guess my question for you is that how do you sharpen your paper, firstly, to say this is a general and important issue, is how technology is affect inequality. And secondly, historically, this is how it's been solved. And I think this time is the same. The priority is still the growth. If you look at Europe, if you don't have growth, there's nothing to talk about. Then historically, people affected, they will be forced to do something else or whatever it is. And the government should provide a different role, something like that. Now, my last point is that I think what is special about digital, I think that's the third layer. Digital can amplify, I think, some of the things because of its the scale economy, scale effect. For example, this like the star phenomenon, right? Something like that. And digital information, because of non-rivalry, it can be amplified. So I think some of the trade-off become amplified. So it could sharpen. But another side of this thing is that we need to think about historically how, I think this is also about the competition. And because if there's a lot of competition, it's almost like the Moore's law, like the computer, the price doesn't really go up, and the utility goes up, and so long as it's not the monopoly, I think a lot of competition will force this to be kind of commoditize the value of the technology. This is what we're seeing in the large language models, in the other stuff like that. So I think the digital is, my point is that this is a general issue. And but I think I'm happy that you use this general issues perspective to talk about this thing. But maybe there's something special about digital that it can amplify this. And also it's all about the competition. And finally, this digital, I think there's another thing special about the digital. On one side, it amplifies the impact. On the other side, it's more inclusive, because let's say other technologies, but for digital, it actually can make everybody benefit. So there's two sides of this. That is a little bit special about the information technology. But my point is push you, Liyan, is to make recommendations for how do we solve the problem. You can't just stay at, say, well, it depends on the sector or stuff, but this is actually a general issue. And within the context of digital technology, how do we solve it? I think that will make your paper more powerful. I guess that's my point. I don't see how Chris or other people would think about it.
Yeah. So can I briefly respond? And you
of course.
Yeah. So this is great comment. No, thank you very much. I briefly respond your first and third comments together because they're related. I think it's also related to what Chris mentioned. I also agree this is a general issue. This is about the general issue of our technology, and as Chris mentioned, so when you make these assumptions, it's better to provide some empirical evidence. I think because now this digitalization is just starting. It's still new. Probably we don't have a lot of empirical evidence. That's why we think of we use some anecdotal evidence to think about this to motivate our assumption. It would be ideal. So and also related to what you talk about, what is special about this time relative to the previous time, and I also think that a lot of them overlapping, something new. It's indeed we need to push further the new thing. I make 2 points. The first point is why, so the literature has focused on the widening, the relation between technology, the positive relation of technology and the income inequality. So why income inequality becomes higher when you have technology progress. I think that's because that's the fact. That's by design. So over time, the empirical evidence is showing that over time, both within group and between group, inequality, wage inequality becomes higher. So that's why people wrote down theories to explain that. To have kind of about 4 or 5 kind of strands or literature explaining this, so like a globalization, unionized things, this kind of thing, automation. And this kind of something happened. The data tell you this is the fact, and then you write a model to explain that. So for digitalization, I think this is still at the early stage. We don't know what's really happening now, and we think about what we observe the assumption, and observe we guess, we conjecture, we make a reasonable guess which one is more first order, and then they try to make the prediction in the next step. This is my first thought. So why what's really new, what's really in this literature, in this paper. The second thought is about I think also when we write down the model, we also found something new, something old. So this one, I think this is something common to all the technology. So when you have a new technology coming, so whether it's digitalization or steam or electricity, it always make your kind of the existing labor, the low level labor, sort of outdated. I think this time nothing new, and that's why we make the assumption here, which is the demand. But for the supply, I think this is something we think probably is new. This is related to the difference between eta S and eta U or this kind of thing. We think this like the matching the driver thing. This is something really related to digitalization. So only if you have this app, you can save your time of finding another finding a rider for the driver. So this is something new. What is really new in our model here, but it's still at a very conceptual level. It's a very reduced form. You mentioned the competition or inclusiveness. I think all these things we need to think about more about I/O structure. Think about how those producers will interact with each other, how this technology affects them. So in our model here, that part is very, very abstract because our labor demand side, the producers are all competitive. We don't have that element there. And for the all-inclusive, we also don't have that feature. Here all the individuals can participate, but I think that can be a good direction. Maybe it's related to aging topic. If people become now aging is also a very important topic, and maybe because this technology will expand the workforce, so maybe captured by increase of this L in equilibrium. So in the model, our LT equilibrium will be a constant in the BGP. So maybe this will change. But I agree with you. This is something general. We need to think about what's really new and what's really new about this digitalization. So here, a lot of things are reduced form. So the demand side is old, the supply side is new in our model specifically. And this is my answer to your first and the third question. To your second question, is about which part is more important, growth and the labor division and inequality. I also agree with you, and I think from my observation, that's also what happened in history. I think this is also related to probably political economy. It's not only about economics. It is related to how the governors, how the government officials, how election, public finance affect the objective function of the government. Maybe because if the government, employment is their first order, and GDP is their first order, so they will put focus on this. I think it's not only about the economic paper, it's also a political paper that can tell you so which one should be the priority. Or if you think about welfare, then it's a deeper question. Then you think about how you compare fairness, how you think about how fairness affect your welfare. It's about the aggregation of individual welfare. I think that's a deeper philosophical question. So it's like a fairness versus efficiency. It's not easy to answer. The second question is, I think, the more philosophical. Thank you.
But I think
let me just tell you something, Lee. I think you kind of I think you complicate the paper too much. I don't want to put your paper down, but look, the general point which Long hinted at is that when there is a new technology introduced, then it affects different types of workers differently. Then inequality increases if it augments skilled workers more than the unskilled. It decreases if it augments unskilled workers more than skilled. That you can never escape that principle if you have a competitive equilibrium, because you know that augmentation means you increase the productivity of skilled and unskilled, and that's the end of the story. Productivity matches wages, and there is nothing more you can say. Now, where I see your contribution is, and I think it's a good contribution, but it's an empirical issue rather than theoretical. The theory is very simple, is that when we look at digital technologies, then although most people in the existing literature think of digital technologies as augmenting highly skilled people, you get publications like the Stanford report saying that digital technologies make managers more effective because they can use the technology instead of others and so on. You're saying that maybe even at the unskilled level, and the Uber example is very good, they augment the Uber drivers in this case, their productivity, because they don't sit idle as long as they were sitting idle before as taxi drivers, where you held them down. And therefore, their wages per hour should go up. And so there is a force that works against inequality. That's it. There isn't anything more to it. I mean, it's a big point. But the point is really empirical, because the theory has been talked about and worked about since the 1980s with the polarization effect and all that. And there's been a lot of empirical work by David Otter and his co-authors on whether software, IT, augmented more high income, low income, or middle. That we know that it worked against the middle, but it augmented higher incomes, and that's how you got the polarization effect. That's finished now. And if you are going to argue, where I think there might be a point that the current digital technologies are augmenting unskilled labor, and we don't know by how much, but this augmentation works against increased inequality, then it's a good point. But the onus is on you to show us the evidence that it matters.
Yeah.
Now the other bit on the cost of learning the new technology, it's also a valid point, but I think there you got the intuition wrong. I'm sorry, I have to tell you. Like if you have a technology that applies to all types of workers, but the ones who use it first are the ones who learn it fastest, then those are going to be the skilled workers, right? I mean, if you say, if I use my mobile phone, my smartphone, to increase my productivity, then the one who is going to learn how to use a smartphone effectively to increase productivity is the one who is going to get the bigger rise in income. And if there is a difference in learning, I would expect college graduates or skilled workers to learn how to use it faster. I still come across people here lower skill doing jobs. And when I tell them, send me a message, send me a WhatsApp and all that, send the pictures, say, oh, I'm sorry, I don't know how to use this phone. I just hold it there to answer phone calls from my kids. I mean, you might think it's very simple to do it, but there are many people who don't know how to use the new technology, and they don't. Well, obviously, in that case, the inequality works in the opposite direction. It's done wonders for me, for example, but it hasn't done wonders for my cleaner at home.
Okay, thanks, Chris.
But it's an empirical issue. You need to convince us. You have to show us numbers.
I see. Basically, Chris, you said that Uber example will correspond to ETU higher. That learning example will correspond to ETS higher. in the conceptual framework, and they need some empirical evidence to support the magnitude.
Yeah,
exactly.
You do have a good point though in that the digital technology is not necessarily complementary to highly skilled. And of course, economists also love introducing new words for concepts that we've known forever. What does augmentation mean? It just means that the technology is complementary to labor. And what does substitution mean? It means that substitutable. Why do we need another word, augmentation? And now everyone is talking, there is substitutability and augmentation, and we should work for augmentation if we're going to use AI. It's all new jargon just for some people, for more people to establish new terms so that they're associated with their name. I think that's all there is to it. Speaking like a wise old man. Yeah.
Okay. Yeah.
Sorry.
Yeah. Yes or no?
Yeah. My last. I think you. So Liyan, I think you need to ask a little bit more of so what, or you get a sense of that in your paper. So you're saying it depends, which is of course fine. It's true.
Yeah.
But so what? You need to get some of the implication that is valuable to the real world. I think that will make the paper go a little bit further. That's my point.
I think great minds are always similar. You and Chris always point to the similar direction. Basically, I have the empirical evidence on the magnitude, that will tell the situation, and then we can act accordingly. So basically, I need some empirical evidence to quantify this size, the difference between ETS and ETU. The anecdotal evidence tell us this ETU can be higher in the example of Uber, but in the example of learning, the ETS can be higher because stupid people cannot pick up phones. That's the story. But we need to find evidence to show the magnitude, which one is higher, how strong it is, how it will resolve the inequality, contribute to the inequality. Data. Yeah.
So to me, the pattern is already somewhat clear because I'm somehow closer to the practice. I've been talking to one of my students who is kind of running one of the largest hiring platform in China. Then basically there will be more and more part-time gig workers because there will be fewer and fewer fixed jobs. That's how I think after the sequence is that I think firstly, Chris is kind of saying, well, the unemployment rate is not going up, but some of the people will be replaced and they need to be happy with what they do later. Then I talked to my student and told me that gig workers will be many more. Fixed jobs were going down because it's just to the benefit of the firm or this efficiency stuff. And also, if you look at in China, like the hailing industry, it's like the China version of the Uber and the fast food, like the delivery industry. They are the biggest sectors. They are absorbing those gig workers, and there are some people who are very talented. They can find things and use the technology, but a lot of people will go to those things. But I think the impact is clear. This round is different. this round will reduce the average number of the employee in a firm. I think this is the thing. Anyway, I'm just chipping in a little bit, and if you want to know more, we can talk more later. Yeah.
Thank you.
I have to leave you. Thank you very much because
thank you, Chris. Thank you very much. Thank you for the great comments. Thank you.
Bye. Yeah. No problem. Bye.
Okay.
Okay. Any more questions, or we can thank you everyone for joining us today. And a big thank you for Professor Yang for these valuable insights on the impact of digitalization. So if you want to stay connected, you can also follow Luohan official WeChat account or join our email list. So we also look forward to seeing you next time.
Thank you. Thank you very much. Thank you, everyone.
Thank you, everyone.
Thanks, everybody. Bye for now.
Thank you. Bye-bye.